Welcome to Mitchell Maths. In this video we're going to have a look at similar shapes involving areas and volumes. This video is going to assume that you know about similar shapes and sides, so if you don't know about that, please check out my other videos. Now, when considering area and volume, it's very important to know how the different scale factors work. So if we take two squares, for example, I have a small square and a bit of a bigger square. I've got a 1 centimetre square and a 2 centimetre square. And we can see the ratio of the lengths is 1 to 2. So, well, the scale factor of the lengths would be 1 to 2. So the scale factor would be, put scale factor up there actually, would be 2. Let's have a look at the areas. Well, the area of this square, if it's 1 centimetre, 1 times 1 is 1. And the area of the larger square would be 2 times 2 is 4. Well, 2 times 2 is, so 4 divided by 1 is 4. Which is, so what we've done is we've squared 2. And we've got the scale factor for the area. Now let's have a look at the volume. So if we make these into cubes, well, a 1 centimetre cube would be 1 times 1 times 1, which would be 1. And the 2 centimetre cube would be 2 times 2 times 2, which is 8. 8 divided by 1 is 8. So and that's the same as 2 cubed. 2 cubed is equal to 8. So we can see from this that the scale factor, to go from the scale factor of the length to area, we've squared the scale factor, which is 2. And to go from the scale factor for the length to the volume, we've cubed it. 2 cubed is 8. And that works for any shape. So if you just think back to the cube, the 1 centimetre cubed and the 2 centimetre cubed, that's why you square it, and you can see why you need to cube it when you go to volume. Let's have a look at a question. Shape A and shape B are mathematically similar. Calculate the surface area of shape B. We've got the lengths and we need to find an area. First thing I'm going to do is I'm going to find out the scale factor for the lengths. Well, 5 and 12.5 centimetres, those sides are proportional. So scale factor is equal to 12.5 divided by 5, which gives us 5 over 2 or 2.5, whichever way you like to do it. Now what I'm going to do is I'm going to need to square the scale factor for the length in order to get the scale factor for the area. So if the scale factor for the area would be equal to 5 over 2 squared, which would be 25 over 4. Now that I've got the scale factor for the area, I can work out the area of the enlarged shape. Because I'm scaling up, I'm going to need to multiply 32 by the scale factor for the area. 32 multiplied by 25 over 4 is equal to 200 centimetres squared. Okay, so that's how you use scale factors when you've got scale factor for the length and you need to scale up the area. You're going to need to work out the scale factor of the length and then square it. Now we're looking at a question that's involving volumes and lengths. And I've got 2 volumes and I need to find a missing length. I'm going to use the 2 volumes to find the scale factor of the volume. So I'll just put SF in brackets V. So the scale factor of the volume is 243 over 72, which is 27 over 8. Now I know that I need to cube the scale factor of the length to get to the scale factor of the volume. So if I'm going the other way, I'm going to need to do the opposite, which will be cube rooting. So to get the scale factor of the length, I'm going to cube root 27 over 8, which will give me 3 over 2. And because I'm enlarging, because I'm going to the bigger shape, I'm going to multiply 6 by 3 over 2. And 6 times 3 over 2 is 9 centimetres. So y is 9 centimetres. So if you go in the opposite way with volume scale factor to the length scale factor, you need to cube root. If you're going from the scale factor for the area to the scale factor of the length, you're going to need to square root. Shape A and shape B are mathematically similar. Calculate the area of shape A. Right, so this question's given us scale volumes and it's given us areas. And we can't directly work out the scale factor of area from volume. But we'll work out... Right, so the scale factor of the volume would be 270 divided by 90, which is equal to 8. So it's 720, isn't it? And if we want to find this scale factor of the area, we need to first find the scale factor for the length, which is, well, if we go from the scale factor of the volume to the scale factor of the length, we need to cube root. So the cube root of 8 is 2. And then, because we've got the scale factor for the length being 2, we can square that to get the scale factor for the area. So if you ever need to go between the scale factor of the volume and area, just work out the scale factor of the length and then do it that way. So the scale factor for the area is 4. And because we're scaling down, what we're going to need to do is we're going to need to divide the area by 4. 280 divided by 4 is equal to 70 centimetres squared. Okay, so that's when you get when you've got volumes and areas. In this question, the length of the prism A was 50% longer than prism B. The volume of prism A is 1080 centimetres cubed. Calculate the volume of prism B. Well, with this question, we have a volume for prism A, but we don't have any lengths and we don't have any areas. What it did tell us in the question, though, that was prism A was 50% longer than prism B. And if we write that as a ratio, well, 100% plus 50% is 150. And so it's 150 to 100. And in order to find, and we can scale that down, we can divide both sides by 50, which gives us 3 to 2. And if we divide them, 3 divided by 2, well, we can write it as 3 over 2, or you could write it as 1.5 if you want. So that's the scale factor for the lengths. And we know if we want to go from scale factor for the length to the scale factor of the volume, we need to cube it. So 3 over 2 cubed would be 27 over 8. And because we're scaling down, we can do 1080 divided by 27 over 8. And that equals 320 centimetres cubed. So if you do get a question with a percentage in, saying something's some X% longer than this, write it as a ratio and use a ratio in order to work out the scale factors. And you might actually have some questions where you do have ratio and you need to work out the scale factor from that, so do make sure you know how to do that. Question 5. This is a worded question. Andrew makes a clay model of a statue. The model is made from the same clay as the statue. The surface area of the base of the model is 4 centimetres squared, and the surface area of the base of the statue is 150 centimetres squared. Andrew used 2 kilograms of clay to make the model, and the clay comes in 10 kilograms bags. Calculate the number of bags of clay which will be required to make the statue. Well, if we're looking at how much the mass of clay that we need, then the mass is sort of like the volume. It's important that it's the same clay because it means it's the same density. Right, so the first thing I'm going to use is I'm going to work out the scale factor of the area. So I'll just write it here. Scale factor of area is equal to, well, it's 150 divided by 4, which gives me 37.5. And remember, when you're using scale factors of areas and volumes, you need to work out the scale factor of the length to switch between them. So the scale factor of the length would be the square root of 37.5, which is going to give us a decimal. So that would be 6.1. What I'd do though is I'd keep the answer in your calculator so you don't get any rounding errors. And then you'd need to cube that value in order to get the scale factor for the volume. So it'd be 6.1 cubed. In your calculator though, you'd click answer cube, which is what I did, which got me 229.6. So that's the scale factor of the volume of the volumes. And again, you keep that in your calculator. Now, you know Andrew used 2 kilograms of clay to make the model. In order to work out the mass he used for the actual statue, you're going to need to do 2 times the scale factor for the volume. 2 times 229.6, or 2 times answer, would equal 459.3. And then you can do that divided by 10, so 40, just over 10, and that equals 45.93. So you need over 45 bags, so even if it was 45.1, you still need to round up because you need to know how many bags does he need to complete the statue. So it's going to be 46 bags. And yeah, there was a very similar question on one of the specimen papers, which did show where you had to do basically the same method as this. Right, thank you for watching. Hope you found it helpful. If you'd like to see more videos, please click the subscribe button. And for practice questions, please visit my website, www.mitchellmathsandscience.com. The link is in the description.